The Apollo Saturn V, America's largest space vehicle, is being developed for extensive manned space missions, including landings on the moon prior to the end of this decade. One of the most important steps in creating a useful space vehicle is the live development testing of the propulsion system. These tests, called static firings, involve strapping down each stage of the vehicle and firing its engine. In 1965, the propulsion system for each stage of the Apollo Saturn V vehicle was successfully static fired. These tests prove the various propulsion systems are reliable enough for astronaut safety and powerful enough to achieve the assigned mission. The static tests also confirm the design and manufacturing concepts for the production of the flight stages of the vehicle. The Apollo Saturn V consists of 3 booster stages and 3 spacecraft stages. The primary booster stage is the S1C. The upper stages are the S2 and the S4B. The 3 spacecraft stages include the lunar module, the propulsion module, and the command module. The command module is the only vehicle stage which does not have a propulsion system. However, it does contain reaction control engines. Atop the command module is the launch escape system, which is used to pull the spacecraft clear of the launch vehicle if the mission is aborted during liftoff or the early stages of flight. At Huntsville, Alabama, the first stage of the Apollo Saturn V is being developed jointly by the Marshall Space Flight Center and the Boeing Company, and is manufactured by Boeing at Marshall's Michoud Assembly Facility in New Orleans. Static tests of the first stage's propulsion system started at Marshall early in 1965. The stage is powered by 5 F1 engines, which develop a total of 7.5 million pounds of thrust. The engines are produced by Rocketdyne at Canoga Park, California. The purpose of the first stage is to provide the initial boost of the Apollo spacecraft into Earth orbit. The first 5-engine static test of this stage was conducted in the spring of 1965. Since then, many more tests have been conducted, including engine gimbal tests, and full duration tests of over 150 seconds. At Downey and Seal Beach, California, the Saturn V's second stage is being developed and manufactured by the Space and Information Division of North American Aviation under the direction of Marshall Space Flight Center. This stage is powered by 5 J2 engines which develop a total thrust of 1 million pounds. These engines are also produced by Rocketdyne. The J2 is the largest engine currently in production which burns liquid hydrogen and liquid oxygen. The development and use of these propellants represent a major step forward in obtaining the necessary power required for manned exploration of space. When mixed with liquid oxygen in a rocket engine, hydrogen provides about 40% more thrust per pound of fuel than the conventional kerosene-type fuel. At its Santa Susana test area, North American has conducted a number of successful firings of the second stage's 5-engine clusters. These included full thrust and full duration tests. The Douglas Aircraft Company at Santa Monica and Huntington Beach, California, is responsible for the development and manufacture of the third stage of the Apollo Saturn V under the direction of the Marshall Space Flight Center. Stage testing is conducted by Douglas at its Sacramento test site. The stage is powered by one J2 Rocketdyne engine, which develops 200,000 pounds of thrust. The purpose of this stage is to first place the spacecraft in an Earth parking orbit, and later to place the spacecraft in a lunar trajectory. To accomplish this, the stage's propulsion system must have a stop-start capability. This capability was successfully demonstrated by test firing in the summer of 1965. The engine was fired for 180 seconds, then shut down for 1.5 hours, simulating a coast period, and reignited for 335 seconds. The lunar module is being developed and manufactured by Grumman Aircraft at Bethpage, New York, under direction of Manned Spacecraft Center at Houston, Texas. The module has two propulsion systems, a descent engine and an ascent engine. The descent engine is being manufactured by TRW in Redondo Beach, California, and tested at San Juan Capistrano, California. The descent engine can be throttled, allowing the astronauts on board to control the module's rate of descent to the lunar surface. The astronauts will also use the descent engine to help translate or move above the lunar surface to select a landing site. The first static firing of the descent engine took place in the spring of 1965. The lunar module's ascent engine is being manufactured by Bell Aerosystems, Buffalo, New York, and is being tested at White Sands Missile Range. The ascent engine supplies power for launch of the module from the lunar surface into lunar orbit, where it will rendezvous with the command and propulsion module. The first firing of the ascent engine also took place in the spring of 1965. The Apollo spacecraft's command and propulsion modules are being developed and constructed by North American Aviation in Downey, California, under the direction of Manned Spacecraft Center. The engine for the propulsion module is being manufactured by Aerojet General in Sacramento, California. The module's propulsion system provides power for maneuvering the spacecraft during its flight to the moon, slowing it for lunar orbit entry, and thrusting the spacecraft from lunar orbit into a return flight path to Earth. The first firing of a development engine for the propulsion module took place at White Sands, New Mexico, early in 1965. There are other propulsion systems in the Apollo Saturn V which are smaller than the systems just reviewed, but which are just as vital to the success of the mission. Some of these systems use liquid fuel, others use solid fuel. They include the reaction control systems on the spacecraft's command, propulsion, and lunar modules, and the reaction control system on the third stage. All of these systems have been successfully tested. Another of the smaller but vital propulsion units is the launch escape system. This is used to pull the spacecraft clear of the vehicle in case of danger to the astronauts in the early stages of powered flight. This system has not only completed static firing, but flight tests as well. These propulsion system development tests are just the beginning of the Apollo Saturn V static firing. For each flight stage of every Apollo Saturn V will also be static fired to verify its power, performance, and reliability. These static tests are a prelude to the launch of the huge vehicle from the Kennedy Space Center. A prelude to the flight within this decade, when the proven power of Apollo Saturn V will launch man on his greatest voyage. A journey to the luminous satellite of Earth we call the Moon.